In this video, we introduce PersonaBooth, personalized text-to-motion generation. Imagine a scenario where, by recording just a few basic movements of yourself, an avatar in a virtual world can mirror your personal traits and unique motion style. Moreover, if avatar motions could be directed through text, creating video content would become easy without the need for real-life stunt actors. In this paper, we propose a task called Motion Personalization, which aims to generate text-based motions that reflect individual personas using a few key atomic movements, such as jumping, punching, or walking. We define a persona as the unique style expression of an individual. As shown in the video, this task aims to generate a broad range of realistic motions robustly. Text-to-motion generation uses only text as input, while motion style transfer relies on a single source motion, limiting diversity. To overcome this, we propose a motion personalization task that generates diverse motions from multiple sources, along with our model, PersonaBooth, and benchmark, PerMo. PersonaBooth is a multi-modal fine-tuning method for pre-trained text-to-motion diffusion models. We aim to fine-tune the pre-trained text-to-motion diffusion model, and we propose a multi-modal fine-tuning method for this. The main challenge in fine-tuning diffusion models for the motion domain is the significant distribution gap between the pre-training and fine-tuning datasets. Motion datasets are smaller and less diverse than image datasets due to high acquisition costs, and pre-training sets like human ML3D rarely capture personality traits, making persona-focused fine-tuning even harder. To tackle this, we introduce textual fine-tuning path as well as visual path. Existing methods consider only the visual features of the input motion and rely on a fixed text feature, which limits their ability to incorporate new data into the textual component. This inflexibility can lead to a phenomenon known as forgetting, where the pre-trained model loses its initial capabilities. To address this, we introduce learnable persona tokens to capture persona features from new data. We construct auxiliary sentences in which the persona token precedes the subject. Subsequently, we propose an adaptation scheme that integrates both textual and visual modalities. Another challenge is extracting a consistent persona across different atomic motions, which manifests in diverse ways depending on the action content. For example, the elegance of a ballerina may be reflected in her footwork while walking and in her hand movements while waving. To address this, we introduce a novel contrastive learning-based loss specifically designed for text-to-motion diffusion, called persona cohesion loss. This loss facilitates cohesion across motion features with different content but the same persona. In addition, we propose context-aware fusion method for multiple motions. In the image domain, existing methods such as Instant Booth simply averages persona features, but this leads to unnatural blending in the motion. To address this, we introduce context-aware fusion, which assigns weights to the fusion of persona features based on the similarity between the prompt and input motions. Here, we use motion clip to check similarity between motion and text. We collected a large-scale PerMo dataset, capturing personas from multiple actors. To ensure variety, we hired 5 professional motion capture actors of diverse genders and body types. Each actor is assigned to perform 34 styles, resulting in a total of 170 personas, and perform 10 distinct contents for every style, carefully selected to engage different body parts. Notably, PerMo is the first dataset to collect data from multiple actors. Our dataset also offers the highest number of total clips and content categories among trainable datasets, and is the only one that includes mesh, marker data, and descriptions. This video compares results with recent methods. Other approaches tend to struggle with accurately following the input prompt. Some methods simply replicate the input motion rather than adhering to the prompt. They also fail to fully capture the persona of the input motion. In contrast, PersonaBooth precisely follows the prompt while fully preserving the input persona. For more information about the model and dataset, please visit our project page.